Let's get started writing some code for our first-person character controller. The first thing we want to do is on your games folder here, right-click, let's create a scripts folder. So folder, rename it to scripts, and this is where our C# scripts will live. Right-click your scripts folder, C# script, and let's go ahead and name this player. Before we can begin, we need to select our player, and we need to add a character controller component. And just by searching, you'll see character controller, add that component, and go ahead and remove your capsule collider. The reason we can remove the capsule collider is because on the player, it actually gives us a capsule collider with the character controller. Now with the character controller, we have a few properties here, such as we can specify the min movement distance, we can specify the radius, so how thick our character is if we were to use a third-person character. We can map this to our player model. For us though, being a first-person shooter game, it's not going to matter, but you can go ahead and keep these values as is, as we're not going to really be messing with these. So let's go ahead, open up our script, and actually before you do that, go ahead and add the script to the player by dragging it on top of it. And now that our player has our player script, let's go ahead and open it up, and let's get a reference to the character controller that's attached to our player. So remember, to do that, we use getComponent. GetComponent allows us to create a handle and then assign that handle to the component so that we can use its properties and methods. So inside our script here, let's go ahead and create a private variable to grab hold of our character controller. So we'll say private character controller underscore controller, and then, whoops, sorry, accidentally hit Control Z here, underscore controller. And then what we want to do is we want to say underscore controller is equal to our character controller that's attached to this object. So the script is already on the player, so we can just say get component character controller. Now we have access to our character, and more specifically the move method. So if I type underscore controller dot move, this is actually how we're going to move our character, and you're going to see here it takes in a vector3 motion, which is going to be our direction of travel. Remember, a vector3 is a position type variable. So if we're moving left, right, back, and forward, then we're changing our current position. So we need to pass in a vector3 here. So let's go ahead and move down to our update method and figure out what the first steps are for this. We're creating movement for our player. This is going to be our physics-based character controller. The first thing we need to do is we need to specify the direction our player is moving. So let's go ahead and create a position variable to store the direction. So we'll say direction equals a new vector3, and this is a 3D game. So we're going to be moving along the x-axis, which is going to be our left and right, and we're going to be moving along the z-axis, which is our forward and backwards. We're not going to be moving on the y-axis because that would be our gravitational axis, which is going to be up and down. So here's our direction, and it needs to be based on our user inputs. So how do I know if I'm going to the left or the right? Similar to game one, we can use the input manager getAccess. So for our x value, we're going to say input.getAccess, and we'll say horizontal, and then 0 for the y, and then we'll say input.getAccess vertical for the up and down arrow keys and the WS keys for our z-axis. Input.getAccess, and we'll say vertical. All right, so what's next? What could we do next? Well, we have our direction vector of where to move. Let's go ahead and apply it to our controller. So let's go ahead and say underscore controller dot move, and let's pass in our direction. This direction variable is going to be based on your user input. So basically, if I hit the left arrow key, then the vector is going to be -1, 0, 0. If I hit the up arrow key, it's going to be 0, 0, 1. Let's go ahead and save this. Head back into Unity. Go ahead and run the game. And it looks like we have an error here. And I added one too many closing parentheses. Save this. Head back into Unity. Go ahead and let it compile. Okay, run your game. And when you hit the A and D key, we should be moving our character. and you'll actually see that input axis horizontal is not set up. I have an error because I misspelled horizontal. This name must match what's in the input manager. And if you don't remember where to get that name from, you can go to Edit, Project Settings, Input. And inside the axes, we have horizontal and vertical. And these map to our WSAD and up and down arrow keys. So here, let's rename this to horizontal, save this, let Unity recompile, and we can go ahead and run the game. And now you can see here, I can go ahead and run around. Now you'll notice though what's happening. We're moving super quick. Do you know why? The reason why is because we're not incorporating real time. So what we want to do now is go ahead and add time.delta time to our direction. So multiply that by time.delta time, save this, head back into Unity, let it compile, and let's test it out again. And here you can see, now we're moving at a much slower pace. And as you can see here, our controls are mapped backwards. And we'll get to that in a later video, but for now you can ignore it. As of right now, our character is moving at 1 meter per second. So what we can do now is we can go ahead and create some velocity for our player. And the reason why the controls are backwards, by the way, is because our camera is flipped 180 degrees. When we actually go ahead and create the first person camera for our player, this will be fixed. But for now, don't worry about that and focus on actually getting this character to move. As of right now, in 2 lines of code, we have created a character controller that we're going to be using in this game. Now we're going to go ahead and modify this by adding a speed variable. Let's go ahead and move him about 3.5 meters per second. Open up your script, and let's go ahead and create a speed variable. Let's go ahead and say private float, we'll go ahead and call it speed. And let's set that to about 3.5f. Now in order to change this in the inspector, in case we'd like to modify it, we need to add the attribute serialize field. Save this. And now how do we actually apply this? Now we could definitely just apply it to our move method, but let's go ahead and keep it consistent with what we're doing. We're creating a physics-based character controller. We have our direction, and we have our physics movement. What is velocity? Velocity is just speed with a direction. So what we can do is create a new vector to store our velocity. So here we can say velocity equals exactly what the formula is, which is direction, which is what we just received from the user based on their user input, multiplied by our speed. We can save this, and then right before heading back to Unity, we need to update our move method. We're no longer moving based off our direction, we're now moving based off our velocity, which is our direction modified by our speed. So here, let's head back into Unity, save this script, let it compile, run your game, and we now have a physics-based character that can move based on a velocity that we set. And as you can see, it's very smooth, which is the benefit of using a character controller movement system. The last thing we may want to do is apply gravity to our player. You'll notice that he's hovering above the ground right now. Let's go ahead and create a gravitational force that's going to drag him down. Go ahead and stop playing, head back into your script, and let's go ahead and create gravity. So here, we're going to go ahead and say private float, and we'll call it underscore gravity equals 9.81 F. That is the actual gravitational force here on Earth, and that's the value we're going to use for our character. Before we do any movement on our character, we want to make sure that we're grounded. So every frame, we're going to have gravity applied. So to apply the gravity, we need to affect the y value of our velocity. So we're going to say velocity.y, and then we're going to just subtract gravity from it. So we're going to say minus equals gravity. And that's all we have to do. Go ahead and save your script, head back into Unity, run your game, and our character should drop to the floor. And you'll notice that he is on the floor now because he has a constant gravitational force of negative 9.1 on his y-axis. And if you actually look at the player, if I try and lift him up, you'll see here we naturally created gravity. We just did the work of a rigid body within 4 lines of code. So it's much more efficient sometimes to eliminate all the need of the physics system and create your own character controller. So what I want to do before I leave you here is I want to explain the logic one more time and briefly cover this, because I know this is daunting and intimidating, and for this game specifically, this is the most advanced part of this game, is creating the physics-based character controller. Understanding that our position is based on our user input, and understanding that velocity is just a formula that's our direction with our speed. And then applying gravity. Why do we have to type velocity.y? Well, we don't want to add or we don't want to subtract gravity on our user input. We only want it on our y-axis, right? When you jump, you need to come back down. And that's what the gravity is doing here. And then to move it all together, we just use controller.move, which is a magical function by Unity that says, okay, you're moving at the direction and speed going left, and then you want to incorporate real time right here. And that's all we're doing. So before we go, let's go ahead and actually clean this up, so it might be even better to read. What we can do here is let's separate our movement access code, like our user input code, from that line of code. So here, let's go ahead and say float horizontal input, and then we can go ahead and copy the input.getAccess horizontal and apply that right here. Add a semicolon, and we can go ahead and say new vector 3, and then now we can just swap it in with horizontal input, and it's much cleaner. We'll do the exact same thing for our vertical. Remove it from here, create a new variable. These are called temporary variables. They're only available within the update method. That's why we're not using any public or private access modifiers. Here we're going to say vertical movement, horizontal input, vertical input, and then we'll apply it just like we did with the horizontal. So on the x-axis is our horizontal input, and the z-axis is our vertical input. Okay, save this. And last but not least, guys, let's go ahead and clean up our update method. Like we discussed, we never want to keep our game loop cluttered. So here we're going to have a method called void calculate movement. Go ahead and put all this code in there. Paste. And let's go ahead and call that method calculate movement, and don't forget to initialize it. Save your script. We're good to go, and I'll see you in the next video.